about a year ago teaching. Bernie, are you in the background?
Yes, Mr. Kes.
Okay, so when I go to it, you can add to it. What we did, and we went through it last Tuesday, please go back on the public teaching of Tuesday. Caroline, it's back again. Go on the teaching of the Tuesday and listen to what we explained about how to make lift, how to start producing, to create lift in your reactors. On the Tuesday teaching, we explained that if you have a coil, two coils in this shape, and you have placed a core inside it, if you allow in your core something like 80% of GaNs, most probably you try your CH3 or CO2, and then the other 20% try to add up hydrogen, making sure that your system on the coils carry at least CuO2. At least you can go for a heavier, the heavier you go, you better. And then what we recommend to you is to add, to create a full resolution of motion into your coil as a mass of GaNs of lead in the base. This GaNs will not move up, but the CH3 and CO2 will move up. The reason for the GaNs at this point is that in the trials has been done, and in the tests we see, and both on emotion wise, the GaNs of lead has what we call the sinking capability. Those of you who work in the world of electronics and computers, you understand what a sinc is. It means that it attracts and absorbs and it holds on to. So you need the GaNs of lead here, where I put it in a different color that you can see, that in the north pole, in the south pole or south entry point, you create a pull that it creates motion in your fields. Very, very small amount of lead can help you. Not much, very, very tiny amount. This will create a pull where it creates a push from the system to feed itself. And that, in that process, you have a CuO2, which is a heavier. You have a light oxygen, or hydrogen here in the center. And in the fields of the GaNs trying to feed the weaker, the rotation of the GaNs inside the tube will start. You have to program this very, very correctly when you're making your system. So you have made the dynamic rotating GaNs without any motors. You might have to adjust your coil a little bit up and down to adjust the gravity. You might have to make your shape slightly different, but take your time. Don't expect you see it there and then. The pressure of what happens, you have the CO2 here, you have the GaNs of, that's a CuO2 here, you have the GaNs of CO2 here, you have the GaNs of the hydrogen here. This, due to the rotation of the GaNs of CO2, it comes to the center. You will see flashing lights at the water point and the GaNs point. Then you see a flashing light at the coil point. Then you see your plasma expanding, because every time the plasma goes out, it creates interaction with the fields, and the two different fields interacting create light. So you see three flashes. If you see three flashes, you should start seeing the motion. So this goes back, if you understood the 129 phenomena. the stronger trying to feed the weaker and putting pressure on the CO2, which is a gas, and it starts rotating. This is how planetary system works. As we explained, the cause of the rotation of even the sun is due to this effect partially. The heavier, stronger gravitational magnetic field of the galaxy, what you call the hydrogen plasma in the middle, or the plasma in the middle, in interacting creates the rotation of the planet. In a way, itself causes partially in that direction too. What you needed was a point, the reason why we get the rotation. How does the system feeds here? Because in the plasma in the center, you have that heavy sinker, what we call as the principal matter, which goes in. In your reactors, you don't have that system. So you create it by a small amount of lead GaNs. Even you can brush it underneath, internally or externally. I want you to be careful with the GaNs of lead. Do not touch it, don't do anything with it, remotely handle it. Now, if you understood this, and then those of you who are making the flight system, I'll put to save it, we call it flight system, whatever is okay. So you got to realize that in your star system you have this, and by putting a right sinc in it, you will create the rotation. And if you add, by moving the sinc, you can decide which one gets what strength. So this, you can dictate you very easily what to do. These are the people who are trying to make a flying system with a control you can control. If you can do it with your emotion, you can create the same thing. But this has a very important application. An important application for it is this. In your coil system, in the stacker system, you connected yourself to electricity. And here you place the load. The load is a puller, is a sinc. That's why, due to the difference of higher, you feed the lower. Now, if we take this out, and now we can use, we would like you to try it, please do. If you put, if I can make a circuitry this way. If you put your batteries, plasma batteries, plasma battery combination, you feed it into your stacker, and then you connect all your appliances, and here you add a sinc. What does a sinc do? In trying to pull, to bring the energy to itself, it feeds all your circuit. And then you have two choices. You can hold in the sinc, or you can connect the end of the sinc to the base end or gravitational end of your plasma. There is a discovery in the Innovation Center, and that is, if you did what we call the Alexis coils, which you fed one back, and one you went to the other one, This first section of your system behaves as a diode. For those of you who don't understand, Bernie will explain to you in more detail. So what it does is that it means you can dictate the direction of the flow of the power. So what you need to do, you need to put one of those first sections of what you use for the beads here, that you make sure that the flow is in that way and nothing goes back into your sinc, that you create the rotation. Here you can use as a sinc exact structure as a battery. With a capacitor on the end. The only thing you need to do, we think, you can check it, is to use the GaNs of lead. In trying the plasma, trying to feed it, it creates a circulation, and this is what we needed, was short, missing in the structure. So if you are correct, please all of you try and come back to us as fast as possible. Innovation Center is ahead of you. We'll have the result within the next couple of hours, most probably by today. This is what you need to do. Everything then is in the structure of the plasma. If you still put the coils in the middle with the GaNs, you increase the enhance the putter process too. So this is two new elements which are adding into the blueprint to change from a power load to a generator. So those of you who can test it, we are testing it. Bernie will go in more detail because he's an expert in it. And interesting enough, all this has come in another person thinking is nothing, but when you get experts like Bernie, we test. As you know, the Keshe Foundation Innovation has number of people around, and our friend in US, to him, as part of innovation, he produced LED, what do you call it, GaNs, and he didn't feel good because he was taking energy, and when he said, hang on, this is what we've been looking for, because now we'll be looking, and then we try to look at it. But if you look overall, in the present energy system, we push field forces in. But in a plasma technology, we have to encourage to draw out of. And that's where the change comes. And that's when we're talking with Wernie and the team, a couple of days ago, I explained this has to come here, because then you create the circulation. And with the annex beads, test your system. I'll give the floor to Wernie to explain to you first about the diode, and then next about the what we call lead GaNs to be used in the battery. Then you understand you can create, it'll take time, but it starts building up, and for the first time we release the design of a generator. It's for you to confirm how it works the way it is, then you can disconnect your system. But we have to build it up. This system has to be built up. This has an application, again, this LED, what do you call it, LED GaNs in the space technology, which the team of Ali is working for, which I told you, you need to create a dump. This is the dump LED from LED. But be very careful when you produce it, with the extreme caution. It creates, I'll leave it, Wernie, are you there to come in and start teaching, please?
Yes, Mr. Keshe.
Okay, please start explaining the diode with a full drawing that you can draw, that people understand how they have to make it. And then go explaining the, what do you call it, the LED construction, what we see it as a sinc. And let's, there we go. I'll go silent and I'll leave it to you. I'll stop sharing.
Okay. Production of
we need your screen. You got to share with us.
Okay, I have to prepare first the writing tablet.
Okay. Do you want me to talk till you come?
Yes, I'll just come back in a few minutes. Okay.
Okay, no problem. Okay.
Mr. Kesh, I have a
So
question.
what do you? Pardon? Carry on.
Is there an alternative to lead? I mean, it's pretty dangerous.
We don't know. This is. It's not dangerous, but if it's done as a GANS, you don't touch it. You don't create any vapor. There is a way to produce a GANS without the vapor of lead, but you can use for the same kind of materials. Put it this way: I've been born around lead, played with it from a very young age, because of the style of life we had. In the X-ray machines, you have what we call a focuser. There's a thing that it puts to absorb any radiation which goes around. It's like a shouting tube, as we call it. You get in the races, they shout at it. They use such a thing in X-ray machines for not spreading the radiation. And these things have been around since childhood. But if you know how to handle it with a lot of caution, there's no danger. Lead poisoning comes out of carelessness. If you are very careful, you don't need much of it. And when he explains to you, even Douglas will explain to you, who started this, that it gives you a lot of emotional sinkage, draining from you emotionally, because lead has a connection with the zinc.
There could be also, this is Alid, there could be also silver oxide. The number on the atomic of silver oxide and lead are very close. Silver oxide is about even 231 and lead is about.
Yeah, it's not a try it, why not? But it's not just by the numbers, it's the behavior. You
behavior.
It's the behavior which behaves that way.
Okay.
So lead has a special structure, Mr. Kesh. So isn't there something similar to the behavior and structure of lead? Similar to lead?
Yes, there are. But there are some synthetic materials which behave like lead too.
But it's enough if we work with gloves and mouth protection, right? I mean, or gloves.
In a way, you need a very small amount of it for one battery, or what you call battery structure in a paper where you wrap it.
Right, thanks.
We're trying. This is literally, this is what I told you. We work literally on the edge of science, and this is the beauty of it. We are not worried who copies it or whatever. And that's how we share. You got to build these things in the time of disaster. You need this. First of all, your flight system most probably depends on it. Your energy system most probably depends on it. This is important. So we see it important enough to literally, as it comes off, and it's still on the process of development in the Innovation Center with Bernie and Douglas in the background, they worked on it. We see it important enough to come on so rapid. And literally can't be any hotter than it, more or less more important than this, and so on the edge than this. So if you see it, you start structuring it, and if you can bring that sinc that it creates the pull from the plasma of the battery, I think we have managed to produce the first generator. Are you ready, Bernie?
Yes, Mr. Kesh.
Now you gotta share.
I would like to for my other account for the screen for me to share this.
Make sure there is nothing on your screen when you share. When you see your screen fully the way what you want to show, then come on. There's no rush.
Okay, I'll have to have a share option first.
Yeah, you have it because our withdrawn is in your hand. You gotta push the green button. There is a lot of things I see getting written on the screen in the background for the boats who want to come to Dubai. European countries do not need my visa. Americans don't need. A number of nations don't need a visa for 30-day visit to Dubai. I see questions coming up. That's why I'm answering till you get ready. If you need a visa, you have to go asking for a tourist visa, and it should be issued very rapidly. The only people who might have or should have what do you call it, any problem with those who have criminal records, or we put them on the list of the criminal records. They will not be allowed to enter Dubai because we provide the list to the securities. And everyone on the third circle and the people connected to them, in communication with them, there's a full list of it will be done. There is something which we'll announce soon. Please, those of you who know how we got damaged last summer by conduct of the man when we exposed his behavior, listen to a couple of broadcasts which are coming out, are very important. Couple of broadcasts are coming out which you can help FBI and CIA in bringing these kind of activities to an end on the internet, at least as part of it. The security services in the United States, FBI, has asked or requested us if we can add, because this gentleman is just about to be more or less soon arrested. We are not doing anything out. He's confirmed it in writing to us. We are releasing his own email, but he's published something on his screen, on his internet, that I had such a conversation with Mr. Cash, but he never disclosed the other part of the conversation, which is in writing, which is a police telephone number, and he's confirming he's being interviewed by the FBI, and he's on the investigation for misusing children. Soon his website will come down. No, it's not our say, it's the national security says. And he is on the criminal investigation for abuse of children, and he's been interviewed, and he's confirmed himself, so we can go public with it, but we won't do it on this net. It'll be done in a couple of public meetings or talks that you know which officers where in FBI you need to speak to. Because in his email we release it, in his communication he mentions the name of the officer, so he says he's been interviewed. You better take all this off, when Bernie.
Okay.
Take all this off and start fresh. There's no use writing it. And just go through the diode section, not the coil section, that what you see, okay?
Okay. This is the beads.
I'm gonna go quiet, all to you. When you finish, wake me up.
Okay. So this is the bead circuits of Ballet. When we tested it on this side, with while checking it for resistance, we're able to see that on one side, where we place the probe here and another probe here, it shows a reading that is around, on the 2000 scale, 2000 ohms scale on the ohmmeter that measures the resistance. It is around 700, 600 plus reading in ohms. While when we reverse this probe, let's say we reverse the probe, we invert the, we reverse the probe, the reading goes beyond the meter can read. So the system blocks one way and allow flow of on another way. So it's acting like an electronic diode. It's very high in resistance on one side, on one flow, and allows flow on the other way. So from that observation, we can classify this in terms of behavior or characteristic. It is just like an electronic diode, the one we use in electronics, diode, that passes one way and that passes flow this way, but blocks going that way. Okay. So we have identified this. We can use this whenever we need to have this one-way flow. However, our connection for this one during our testing is, if this is our circuit, we connected it in this way. We connected it in parallel across our circuit. Okay. Let's move on another page.
Wait a minute.
Yes.
You are a man of understanding. Explain exactly what it means, everything in detail that people can copy.
Okay.
People's life can depend on this in the coming time. So
Yeah.
please go, take your time. You have whole morning.
Okay.
Explain to them how they, because we know partially some people made the Alexa speed and didn't work, or didn't work they wanted it, because they connected these two places the wrong way. And actually instead of doing anything, I cannot, what do you call it? Annotate on your screen. Very strange. So what has happened is that people connected, let's say, the base 1 and base 2 the wrong way around, and the system behaving as a diode has caused the problem. This might give some of you who had a problem and you didn't see working with Allen beads was because you connected the wrong way, as was just explained by Wernie, that this is important because you should be able to understand the polarity change and how you connect your bases, and then how you connect it to the load. Everything has to be correct. Carry on, please.
Okay. When you verify this, you have the flow, which one will allow a flow and which one will block the flow. You use an ohmmeter set it at the maximum range, usually at 2000 K reading on your meter. Your meter usually have this dial. So usually if the ohm range is somewhere here, it should be on the topmost, which reads this value. When you put the red here and the black here, the probes, you'll see a reading that is somewhere 700 plus or down to 600 plus on your digital meter. It's fluctuating actually, the reading. However, when you put this on the other side and this one on here, the reading goes up, that it can no longer be read at this range. It's beyond the capability of your meter, meaning it dynamically goes up, the resistance goes up, that it blocks the flow, and it serves like your flow something like going this way, that you have this blocking line for a symbol of a diode. Going this way, yes, you can, the flow can go through the other side. However, going the other way, it cannot, because the resistance goes up dynamically, that the flow is totally blocked. So we can use this as a diode. You have to find out using this which on your circuit that allows the flow or blocks the flow for you to connect it when you use it as a diode. It is important to measure it. We already have this meter, most of us have this, in verifying the resistance of our nanomaterials, the nano-coated copper. So we can make use of this meter also. Okay. So for the LED,
Okay, well, can I ask you a question, please?
Okay.
Because we have a lot of people who join us new. If you can just spend a few minutes and go, just put this aside and show how you made the first bead and the connection to the other. What they have to do, how they do it, that they know how it works. It takes 2 minutes. Most of us know how to make the Alexa speed, but we're getting huge number of people who come for the first time to understand. If you can explain what is the first base of Haaland, the beat, please.
Okay, if this is your bead, the first two component which has this configuration here, these two are the most important part of the whole circuit. In fact, these two is acting like
okay. Stop. Go backwards. Take all this off.
Okay.
Explain what each line means that people understand.
Okay. This line here goes on the...
No, wipe everything out. Rennie, wipe everything out. You think everybody is educated. I'm the most ignorant one. Okay. Okay, go start from the first line. What is the first line? Draw the first line, explain.
Okay, we have here a nanomaterial, a copper nano-coated.
Bravo, perfect.
Okay. You have here your nano-coated copper. You wrap, you have to wrap paper here that is coated with GaNs. You roll it. If the paper should go like this, then you roll it towards here, this part. So this one have coating of GaNs. Then you roll it, so it will form just like a roll of paper with a nano-coated copper inside. Then you put aluminum foil, just like this. Yes, I use the CO2 and the copper oxide GaNs. A very thin amount of mixture of GaNs here, enough to coat the paper. Roll it, and roll it very tight that it roll around the material, the nano-coated copper. Then the same way, you roll aluminum around it, just like this way. So you have an aluminum coating, aluminum wrapping here. Let's make another color. So this is your aluminum. Showing this is your aluminum. This should be very tight. Then you have to roll again another layer, like the foil. Yeah, the foil will do. When you roll the foil, it should
it's
be
a cooking foil, cooking aluminum foil used for cooking.
Yes, correct. Then use a small amount of zinc metal to hold the aluminum. You have to wrap also this zinc. So that's our 3 layers. You have the first layer, that is paper with GaNs here, then the second layer, and the third layer. So you have this, the middle part, your nano-coated copper. This is your paper. This is your yes, this is your. So these are your layers of.
So explain. Let me explain. So when you do put in the paper, they finish rolling it, then they put the aluminum, and then they put zinc.
Zinc, yes.
In one of the tests you did, we got a better performance without the zinc or without the copper if we use one metal. Correct?
Without the zinc, it still works the same, since it is also in contact with aluminum. So we can use without the zinc only on the aluminum layer. Yes, it will work well that way. If you don't have zinc, it's okay. One thing in okay, the paper gun should be if this is your copper, what next layer would be wrapping around the copper wire should be the paper with GaNs. Then next is your aluminum layer. Okay? So the aluminum is wrapping the paper, is around the paper. Okay. Without the zinc, it's okay. For what is very important here is the aluminum wrapping our, let's say this is your whole paper with GaNs, and inside is your part. If you have the aluminum here covering everything, the field interaction on or from the paper is now being captured by this aluminum foil. The property of aluminum is to hold that field. That's why when you put aluminum here, you get a higher voltage like 0. Let's say for example 5 volts DC instead of the usual millivolts range. When you simply put a test probe here, your voltmeter on the paper and on the copper. So you have a meter there, you put that on the paper, you only read around several millivolts here. However, when you put the test probe on the aluminum, you'll get beyond the millivolts range, usually somewhere here in the 0.5 volts range, simply because your aluminum is now covering the almost the entire length of paper. We don't cover everything to avoid the short circuit going to the nano-coated copper, but just enough for the paper to come out here and on the other side. So this whole field of GaNs inside the paper, it has, as we know, GaNs have fields, the nanomaterials have fields. So there are a lot of nanomaterials here from the mixture of GaNs you have. This is where your aluminum is listening to all the field interaction. For that reason, you were able to get this higher voltage reading.
Can I add just a little bit?
Okay.
When you put your GaNs on the paper, you have to allow the paper to dry. It's important. Because if you have water in your wrapping, then when it comes to running the bead, you'll find problems with it. Especially get a lot of explosions like pop. That is when the oxygen or the water molecules try to dry and they pop when the current goes through. So you have to make sure that the paper dries when you put the GaNs on it. It dries before you start using it. Carry on, sorry about that.
Mr. Kesh, can I just ask you, because a few people are also asking whether the aluminum could or should be nano-coated. Now, the procedure that Richard showed last time with this specific temperature and caustic, wouldn't it be better, even better performance on a plasmatic level because of the storage capacity?
I think Wendy can answer you. What's the difference if you nano-coat the aluminum or non-nano-coat?
You have a very hard time nano-coating this aluminum, it's okay.
What about if you nano-coat titanium instead of aluminum we use?
I haven't tried. I don't have
what would be the performance if you use a nano-coating in the outer than using a plain aluminum?
What about copper, Mr. Kesh?
No, you can't use copper because the copper is inside. You can use copper, but it's the what the question is, what is the difference if you have a nano-coated? Would it be any changes in the voltage if you have a nano-coated aluminum or non-nano-coated aluminum?
We have with this configuration, we already have a huge voltage that is larger than our usual. So this is okay for people who cannot nano-coat aluminum. It's okay.
What about if we can nano-coat aluminum? Would we get a higher voltage?
We have field interaction on top and below. Yes, that will result to a more of field interaction, especially on the inside. However, it's very difficult to have this, and it takes experience for anyone to nano-coat this, because if you do this with caustic, you should be very careful doing it. It should be a very light solution and careful not to inhale the steam. For the
Yeah,
sake
but let me explain. Well, look, just burning weight. Rick is there. Rick, what happens when we put aluminum foil with a caustic?
You get your friend hydrogen your friend hydrogen would be generated.
So those of you who, when we spoke about the 80% GaNs and 20% hydrogen, if you put the aluminum foil in a high caustic, high temperature caustic, the gases which come up with mainly hydrogen, as Rick is explaining. So now you know how to produce your hydrogens for your flight system as well, if you're looking for it that way.
Yes, a tiny amount of aluminum and caustic will produce that hydrogen that is needed inside.
Yes, okay. Carry on, sorry.
We use aluminum because this is our aluminum has, as a metal, it has this negative polarity. We cannot use copper because it's on the positive polarity as a material, as a metal. So aluminum fits this in this configuration. Same with zinc, it is on a negative polarity material, so we can use zinc also. But aluminum is more available, like as a wrapper. You can use that, the aluminum foil. I only use the aluminum foil we use in the kitchen, so it's very easy to implement using aluminum this way. So we have, in a way, our purpose here is to cover everything or to capture all the field interaction in one material, which is the aluminum. That's why we're able to get this. Usually with nanomaterials, you only get in millivolts range. With this one, we have a concentrated, or everything is accounted at this configuration. Okay, so this is how we construct. Each of the beads should be constructed in a similar manner. And it should be, before using it on a circuit, it should be dried. Everything should be dry. You can set it on a table, even if it's just set for it overnight. Make sure that the paper outside, you won't see, or it is very hard already, no more moisture. So for, if you use it on an AC circuit, let's say 220 volts, 110 volts, never use when the paper is still wet. Anyway, we have the bead circuit is a very safe configuration for us. It's just like you're multiplying multiple layers of paper across 12 beads outside. Let's say you have 12 beads outside and 6 beads inside that is also connected outside, something like that one. Since your connection will be something like, let's say this is the first bead.
I have to stop you. I have to stop.
Okay.
Now go with the winding of the nano coated wires on that aluminum foil.
Okay. So
before you go to the beads, because we get lost. Now you're there. Explain the next step, please.
Yeah, the next step would be we have to connect this from one bead to another. So the connection would be, if this is the.
Yeah, and you want to clean the board off and start a fresh board.
Okay. So connecting
okay.
Connecting 2 beads. Let's say you have your beads. Let's say this is 1, and then this is the next bead, for example. So we wrap it around. So this is your aluminum here layer. So we wrap it around your aluminum layer. This one also goes to the next. So it is this way. Never be careful on this part, not to touch that. Let's say if we enlarge that portion, you have your aluminum, paper, then the center. It should go this way. Never touch this paper with this wire. Only on the aluminum part. Sometimes you touch this, it will also connect. This is interactive. This one have nanomaterial, so never touch this. There should be an air gap there, so it will be a different reaction when you shorten this part here. Okay, so the next bit will go here, just like the same. Then you have all the 12 beads around, then 6 beads in the middle, and your 2 beads here. So each connection should go like this. All the beads around here and in here. All the beads here are in a circular configuration. Okay. So this is this copper.
Wait. What do we need for a diode process to have all the circle of the beads, or can we just use the 2 bottom one?
We can use this. The most important part is here, the configuration here.
Can you show us that configuration, please?
Yes. So you have here. Okay.
Sometimes does. Let's go through this because a lot of people have a problem. Can you use different color for your? Okay.
Okay.
Because people are getting more confused everywhere.
Okay, the connections is just like this. This is from the other bead. This wire comes from.
You connect it to the bead. You connect it from there to the other bead, yeah?
Yes. It goes this way. Then another wire here. All the wires here are nano-coated. Then wrap around the aluminum part. Again, never touch that paper part. So then it also connects here.
Is it fire nano-coated or caustic nano-coated?
Either way, it will work. For as long as it is nano-coated, it's okay. What we are after here is the field interaction between the materials, and plasma will flow through the nanomaterials. So this is how it is. This configuration alone, this is where your diode characteristics comes in. So the rest are simply but a continuation of the whole circuit.
Can I ask you a question?
Okay.
If you can explain that, because we usually have a feedback to the center pin. Where is your feedback?
Here.
Where is the feedback?
So this should go.
No, I mean from the bead itself. You will have a feedback to the center pin.
Okay.
Actually, I was about to ask the same question also. I mean, given that this is a plasmatic diode, do we need that feedback?
Yes, you do.
Yes, I believe. I forgot where the.
Okay.
I believe it is from here. No. The other one. Yes, it's just the same. It should be from the center going on the surface.
Can you redraw it that we know exactly, because it doesn't take much to confuse people.
Yes. Okay. Okay, let's just draw one bead.
Yeah.
When we apply feedback, say for example here, so this is where your connection for this is a nano-coated wire, and also with this one.
They're asking, can you use color, please?
Yes. Okay. Let's use another color for this one. Okay, this is your feedback wire. Let's say you wrap it here. Then another wire should be a separate wire from here going to the next. So you have your another bead here. So this wire is also connected this way. The feedback is from the middle here towards the outer, the aluminum component. Then this one connects.
Okay, how do we connect this to the circuit? Where are the beads and where do we connect to the power supply?
Okay, on our test circuit.
No, keep it there. Okay, go.
That's a huge drawing. On our test circuit, we have, let's say, we're currently testing the, let's say, the unit. Here is our mag-grab unit. Then here is our load. We place the beads. We're still on testing this somewhere here. We place this is your source here. This is your AC. This is your source here. We place it somewhere here across. So the beads is right here. So when we connect this, say
which bead goes where? Which one? The one with the double winding on it goes where? And the one with the single winding on it goes where?
Okay, we've tried both. We inverted it and we still read the same because it's an AC circuit. Let's say, wait, I'll have to read it first. Okay, we have here, all the joints should have something like this, so you can just, so our beads,
is that without using capacitors?
No capacitors. The beads is acting like your battery capacitor.
Okay, so we're using the beads instead of the capacitors.
Yes, in this case, this is our test. The capacitors on the mag-grab are on the mag-grab. It's somewhere here.
These are the capacitors you're talking about, the capacitors across the grid.
Yes.
You don't need that. You take those four out.
Yes. So this one already serving as another source for the entire circuit.
Okay, can you connect to the rest of the beads to the bead circles that they can see it, please?
So 1, 2, 3, 4, 5, 6. Then you have 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. So you have
which one? Which of the two original capacitors which you join to each other are is the one with the return, the feedback?
Here is the one with the feedback. Here. Then
yeah, but do you feed it back to the grid side or to the loop side?
It's on from the middle part of this. From this one, it goes on the aluminum side.
Yeah, okay. It's not on the side coming from the grid. You connect it to the other side.
Yes, it's not from the grid. It's on.
After the first loop is before the grid.
Yeah, because this is a feedback from the plasma circuit.
Mm-hmm.
So everything in this area, or everything works in the plasma. So that's how it is. Then at this point, this is where the conversion begins, where it interacts with the usual AC or the house line. We use this with a plug. If this is the wire, we use a plug. On that part, we use a plug. So we connected the bridge with a plug. So we simply plug this as part of the whole setup. So it's easier for us to transfer anywhere on the circuit. So this is how we have tested it so far. And we've also tried connecting, instead of from on this point, we also put it somewhere here. With the discovery of the LED GANs that should be added on this setup later.
Going too far, too fast. Wait.
Okay.
You're going too far, too fast. So the one on the top, which comes from the top one, is the live connection, and the one from the bottom is the neutral connection. Okay?
Yes,
then
yes.
People know what to connect it. Your live goes into the line with the feedback.
So if this
and
is...
then it goes to the outer loop, and it comes back in and joins the inner loop, and it goes back on the neutral. This is important. It's absolutely important. Please note this configuration, because then it can cause you a problem. Somebody is asking, how do you connect the beads to each other? You make your beads, and then you connect one bead to the center copper line of the next one. That's how it's done. So you go on connecting from the center line to the next bead. There is a big confusion here. I can see people will come back to us with it. Where you have drawn the white lines, the feedback, this needs to be clarified, because I know a lot of people had the problem when Alex starts teaching.
We have to verify the drawings. I don't have the drawing here. And the test circuit is on another house under the still on testing.
Problem.
Anyway, we will release it. Yes, we will release it, the complete setup, when we have complete results.
Yeah.
But yeah, we can transfer. One can test this. This is anyway. You don't have to worry about this circuit, because no matter how you connect this in the whole circuit, we have multiple layers of paper here. So it's just like a very thick, multiple layers, 12 or actually 24.
No, it's just going about the connections, to do the connections right.
Yes.
This is the problem. So you bring the center loop, the middle one, together, and then you connect it to the base of the other one, and you bring the outer loop and connect it to the base of the inner loop. All come together in one joint and they go in. Correct?
Yes, yes. So the inner loop is connected
with the outer loop.
Yes, yes, with the outer.
Okay, this is important the way it's done, because then we understand the next step. This is what we are testing now. The circuit you've seen now, which is drawn with the beads, this is what is getting tested at the test center in respect to production of 100% zero power supply. This is what is tested. We see it's been tested by Alex too. Alex has this structure too. And other people who use the beads and place them with a core setup, the energy unit or maglev unit, they see the up to 100% reduction. This is what we said to you, we will release when we know. we've seen this, a number of people are using it, and they have seen a full reduction. The reduction has come in since we start putting the beads, adding with the coil, the combination of the two. So what we are considering at the moment under test is to put 2 coil rings plates, 2 of the 3 stacker, and put this bead at the bottom of the stacker. This is what the test is going in the innovation center. So we still have the 3 stacker, but we change the bottom bead to the bottom tray to a bead. We tried and we put the tray on the top, but we see a better results by putting the tray at the bottom, the bead tray at the bottom. Am I correct with that, Bernie?
Yes.
So this is the new configuration for your power supplies. If you are heading for 100% reduction, this is what a couple of weeks ago we told you. We have done a new development, and those of you who received the unit free, what do you call it, as a 20%, 30% reduction, this configuration shows to bring the reduction up to 70, 80% and 100%. And it's very active. So now for the first time, you see more 60 to 100% reduction. It's the first time we release it. It's part of the blueprint. Please take note of it. The Innovation Center will release a blueprint of it in a proper drawing in the coming days. Not only this system works as a diode, you have to use the whole circle, the 2 bottom as a diode. Can you show the drawing how you use the bottom 2 bits as a diode that I understand, please? Now this is on the circuit. Yeah, these 2, how they can use it as a diode.
If you'll use this as a diode, you'll have to connect this in series on one line.
Okay, can you just draw it on the side, please? Can you draw it on the side, please?
Yeah, for example, you want to connect this on, let's say, okay, I'll erase some, just make it.
Don't erase anything, leave that to be, make a new one, please. You can always bring this back.
Okay, using it as a diode.
Yeah. Show us a drawing of the beads and how you connect it, where you connect it. Don't forget they're all ignorant, huh? We know nothing. A few geniuses understand this. You're a bunch of people, amateurs, housewives like me who knows nothing about anything, just watching to learn.
Okay. So, okay. So connecting this on one line, then another, let's say, another line here. You have to find, on your setup, you'll have to find which one where it allowed to flow. So you'll connect it the way where you want the flow will go. So the flow goes this way, then exit the other way, all the way through the circuit. And this is another line. So if this is your, if this part here is the load, so connecting it this way is just like a gate or a diode that is.
Which line is the live line, please?
Okay, if we'll use this on the live, this will be on the neutral, on the line after. So this is where on the top one is our. Okay.
This is if you are using as a diode, huh?
Yes, on the other side.
And the flow is blocked in which way?
This way. It's blocked. So you wait. It's the other way.
It's the other way.
It's the other way.
Can you, okay, can you show us where is the winding from which one to which one?
The winding?
on the two beads.
Ah. Okay, okay, this is this way. So the connection is on the top. But we have to verify first in this configuration. I don't have my copy here, which allow. So the ohmmeter will verify which part of this that will allow the flow towards the other, towards this way or this way. So make use of your ohmmeter. So connecting it as a diode, it should always be in series. Just like a diode, an electronic diode, it should be, the flow should go through the diode. It should be goes through the diode. It's not that diode should be connected across, but it's through the diode. That's how we connect a diode if you want to block one way and allow the other way. Okay? So connecting it in parallel is just like acting like...
but the thing is, but the problem is what we have. We want to make sure the flow goes out of the load. Now the flow is into the load on the neutral line.
It should be out, yes.
So we want the reverse. So you have to change the polarity.
Yes.
You want the flow to be from, I cannot touch that. I don't know why it doesn't work on my system. I cannot come in and change things for you. But what we need to do is that this diode has to be in a way connected that the energy goes away from the load into the grid. So your maximum should be on the right side toward the load side, and your minimum should be on the left side towards the neutral, the N. That the direction goes out, the flow flows out. This is important because once Rennie start explaining the use of the LED in this configuration, it's important that now the current flow is there, but the LED itself, LED GaNs, creates a sink to pull the energy. And what you need to do, where you have the L and N, you can place it with a plasma battery. Am I correct? Ready?
Yes.
Ready?
The placement now for our sink should be somewhere after the load.
Yeah. So you can put, yeah, somewhere there. So you direct it as a supply out. We release a blueprint of this on the blueprint section. But at the moment, you have your N and L, neutral and live, connected to the grid. If you use a sinc, which we're going to show you with the LED now, plus a diode on this circuit the way it is, you can change take the grid out and place a plasma battery, very strong plasma battery, on the N and L. Can I share a screen and then we come back to you again, please, Bernie? This is important because you will understand in a minute. I'm going to get rid of this. You can do a lot of things with this. So what do you do? At the moment, we have a grid. We load, we put the maglev system, we go to the load, and then we feed back into the grid, live and neutral. Now what is proposed, what is on the table, is that forget about the grid, place, mine is moving, place a bit here, or what I call, let me do it, undo it, so do this. Okay. You got a grid, you place a bit plus 2 coils, and this unit is the new power unit. You can use it again for the grid, go to your load and come back, live and neutral. So here, instead of 3 stacker, you have 2 stacker, and the bottom stacker is a bead stacker. The other proposal which we have now, which changes from the 100% reduction relying on the grid to a new configuration where we have the connection. You place the same again, the bit, 2 stacker. You still need a parallel system on your stacker across your plates. This is your new unit. You go out to your load. You feed back after the load a sinc. Werner is going to show you the sinc. Then you add a, sorry, the other way around. You add a diode system here and you come out, which dictates the flow can be in one direction. Here, what you need, you connect to a plasma system, plasma battery system, which we taught recently. We think combination of 4 parallel series should be good enough. So what happens is the flow is in this way. The sinc tries to pull the energy from the plasma batteries. It creates a circulation, and then what arrives here, which is always lower than here, feeding, it starts creating generation of the battery, the power supply. At the moment, this looks like a DC supply. What you can do somewhere here, you can connect your system to earth it, or strip the nano coating from part of the wire and connect it to the neutral. Seems to be the other alternative to create an impulse supply. So now what we're going to talk about is about this sinc. This sinc is very important because it drains, and in draining it creates a flow, and this flow, this is what we've been looking for. And this diode, which just explained by Werner, is to stop anything to flow backwards, and it'll make it one directional flow. If you don't get the system running, look where you're making a mistake. This is what is on the table. Now we have achieved, or it looks like we have achieved 100% reduction. We say, let's say 60%, 70%, by adding a bead as one of the stacker. This is what's going to come out of the factory in the coming days. Then, by adding a sinc outside, a unit sinc outside, with a diode, you create a pull, and in turn, you create a flow. Remember, now this is the 129 box, and this sinc behaves as a weak stacker in the Sensano. And these loads here, they behave as a middle unit. If you remember in the Sano, how we created so much power was we put the GAN system, core star formation, we put a system which was more powerful, and then we put a system in the box which was weaker. In trying to feed, it created a high impulse. So now this sinc behaves as one, demanding, and this behaves as number 3, the star formation. And now you see how the system is completed. Please try this. Bernie is going to show you how to make the sinc capacitor, which is the same as the other capacitor, you've seen it. And then we'll see if you are right. Try this as fast as you can. Those of you who are looking for zinc, you always have it from most of the hardware shop, because in most of the countries, the lead is used for the roofing. Okay, so now we understand the circuitry and everything else. Do you want to add anything?
Is there between the sinc and the plasma batteries, is there the ring of beads, or how are they connected?
No, here is the diode. The diode's here in this position.
The one that has been showed before?
Yes, you can put it there. You can put another bead. In a way, you have two beads. You have one in the stacker, and you have one on the back line of feedback.
That's what I meant. Thank you.
Yes, we have two beads. One on the stacker. If you're still using a DC power supply, what they call it, the grid power supply, you need. This is the breakthrough we have. So when we know more, this is where you can change your power supply from 30% to 100%. And in what it does, you'll find that the nano coating from the box seems to be faster. This is what we see now. And that's what we said. Once we have this confirmed, we provide an additional unit to the people who bought the 700, the units for the grid. And you just add to it, you plug it into this become a new stacker to this. So we are working on it. We think we have achieved 100% reduction totally. And at the same time, in past few days, in discussion between Douglas and Wernie in the Innovation Center, one talking about whatever is Wernie understanding that what we're looking for to create a dumper. Now it has led to this. There is a development further, because then Wernie, before he shows you, you can create an impulse in what is known as a delta star, a delta formation. Wernie will explain to you, where if you're looking for a maneuver or what we call the phase for the system, we have used the system in past few months. Wernie has been building it, where we can create sinusoidal between -5 and +0.5 and -0.5 sinusoidal using what do you call it, a Y and delta formation. Would you like to explain the sinc first, please, Wernie? And then we can go to the next. I'll stop sharing.
Yes.
Wernie and I and Renan, we've been working in the background for past 5 or 6 months plus to test these things. So now, partially part of the test is what you see. And this is part of the Energy Innovation Group of the Foundation. Carry on, please. Can you show us how you make the sinc unit, please?
Okay. First, we have to make a GANs out of the lead metal. This, we have to be very careful. It should be that you're in a well ventilated, if it is best if you're outside the house or outside a room, very good ventilation, because these GANs, the production of GANs using the lead metal is different from, in terms of energy, it's different from CO2 production. The CH3 and copper oxide is really different, that when you're near the setup, your energy get drained by the setup. There's a huge field around it that you can really feel that you're being drained. So we be very careful about it. It happens when our friend in the US, Douglas, make GANs out of lead material, that he experienced very drained condition on his body, that he's not comfortable doing it again. So he put the GAN set up outside the house. When I see that that it happens, I see a different thing other than Douglas is moving away from it. He doesn't want to touch it again, because of every time he goes near it, it doesn't feel good about the situation. It's very, he said, very yucky feeling. I said, So your energy is being drained when you're near the system and when you hold the container. So yes, we've been looking for that drain condition, and now we have it. So let's make use of it to attract or to pull the plasma, so we can initiate a plasma flow around our circuit. So this is where we have this sinc device, or the lead GaNs. We can make it like a capacitor, but it acts like an opposite to that of the capacitor. So
I make you know, a year ago I made you know, lots of it, you know, GaNs of lead, and
okay,
still have it, but I never felt any drainage. You know, I just did a nano-coated copper and lead on another side, and it's a white like CO2, and I collected a lot of GaNs.
Yeah, it started that way, just like CO2 GaNs, but a gel-like substance.
Yeah,
but
a little bit bigger particles.
Yes, and when we did that, and like Douglas did it the first time, I replicated it, and we have the same observation that it drained. It literally drained the energy. Our right hand plasma flows out from our right hand. On our left hand, it goes in. So holding the container of the GaNs, say if this is the container where you do the GaNs production, and here is your GaNs, and there's your seawater. Holding with your right hand, even on this part of the container, will pull that energy from your right hand that it hurts your arm. Using your left hand, it doesn't hurt your left hand arm. So I was very careful when doing this. I'm a right-handed person, so it's not comfortable for me to do the same. What I did to test it again is to hold a container of CO2 GaNs and touch it on my right arm, place it on my right arm and the lower part of my right arm, then use my right hand holding this part. I never felt the same drain again. Overnight, that field, pulling condition subsides. However, when you hold this here, you can feel a very slight pull of energy away from your right hand. But when you go to this level where your hand is in this level, it's the same. I still remember that the same feeling the other day. It pulls the plasma out of your hand that it hurts so much. When you touch your fingers here, as if your the cells, it really hurts. So be very careful, especially there's something like when you do the GaNs production. For example, this is your lead, this is your copper, nano-coated copper. Everything around it, or everything in the room, it's just like it turns like into an acidic condition that you don't like it going near it. That's how we see it. That's how we feel. That's that is our observation. So be very careful when you hold GaNs while going near it. It's okay, as if you have a backup source of energy. It's from the CO2 GaNs that you would get drained.
Okay,
so
can you explain to us how did you make your GaNs of lead, please?
Yes, I make use of a supply. I connected this to this is the, I'll make another color for this one. So this is your, oh, not that one. Show me, this is your lead material. And this is your...
is it nano-coated or not, your lead?
No, you don't nano-coat the one on the positive side. Only the copper is nano-coated. I made the coils on this, at the bottom part, so that there will be more copper material under seawater. The more copper materials, the faster the production. It is for that reason that those who use scrubbers made of copper and nano-coated it, produce a lot of GaNs. There are a lot of nanomaterials submerged in the water. More nanomaterials, more plasma to power your production. Okay, so I connected.
So you put nano-coated copper on one side and
Yes.
just the lead on its own, yeah? And then how did you connect it, please?
I connected it to a power supply. This one goes to the positive of the power supply. So I have here, for example, a power supply. And here's the positive. I connected it here. A DC power supply. I set it to 6 volts. I don't have a much lower voltage, but anyway, it does the job. Okay, so this is the negative part of the power supply.
And you use a seawater.
Yes, I use seawater on all my GaNs production. This is seawater.
When he lives in Philippines, water is everywhere.
Yeah, we are surrounded by seawater. Okay, so there's an unusual, we observe an unusual happening here on our, we have this current meter that has a pointer, and this is 0. It has a label A, means ampere, on this power supply. Usually with the same type of seawater, when I use copper, when I use zinc, when I use an iron nail, it reads 800, 500 to usually 800 milliamperes. Usually 800 milliamperes. However, with using this another material that is lead, it doesn't read 800 milliamperes, but the pointer, if this is 0 and this is 1, 2, 3, 4, 5, 6, then this is 1, the pointer remains at 0. It remains at 0. But there is production, there are bubbles here, lots of production that indicates a similar condition to that reading of 800 milliamperes. Okay, my understanding on this one, since the whole condition, or when you have the initial GaNs here, pulse plasma, what powers the whole production, even if I have this one, is totally plasma. For that, I read 0 current. It doesn't move. There's no even a slight movement. No movement. For that, it confirms that indeed the condition we have created at this moment, where the GaNs have already appeared here and then here, a gel-like substance, a white, then later on turns into something like a purple brown. So anyway, the color greatly depends on how much voltage you apply, but this 0 reading indicates plasma is covering the work of this one. Meaning we can really use this substance or this GaNs to compensate the need of our load with plasma instead of the usual. In this one is the electron flow. So I did not have electron flow, the usual 800 milliamperes. This is the same water. What I understood before is that it is the electrolyte, considering you have a good conductance here and all the wires here, it is the electrolyte that simply determines the current flow. See, water here is...
Or does the nano coating on the copper changes, or it stays the same?
It changes.
The nano coating here, over time, was removed. Then I stopped the process. It was removed, not everything, but some of the materials were removed. But when
you don't have a pure lead GaNs. You have a copper GaNs mixed with it.
Most likely. Okay.
Mr. Kesh, if you don't connect to DC power supply, you connect it to LED, you will get a white color of GaNs, and it's heavier GaNs. You can see it. It's a big particles. you know, and without you know, the supply, you know, you will create more. This way you create brown GaNs, brown lead GaNs, but the other way you only create white.
Yeah, the brown comes because we know when we do a power to the nano copper plates, we produce a brown material. We know that. So
But
the
if,
brown shows that the nano material from the plate, copper plate, are coming out.
yes, but if you do the other way, it's going to be pure white GaNs.
Yeah,
Pure.
we have that white GaNs also. We have that. It's the first thing that comes out. It's the first, and we have a lot of it.
What Arman is trying to say, Bernie, is that
Yes.
if you don't connect a power supply, just take the power supply off and use the LED light
Yes. Yes.
or a small motor, you will get a pure LED at the bottom.
Okay.
Yes. Yes, correct.
You can even
Yeah,
use
it's
a
just we know whenever you use power, high power, especially a bit of amperage voltage on the nano coated plates, copper plates, you get this brown depending on, and if you go very high, you produce a black copper nano coated. No, what they call black copper.
I also use the power supply, but only 1.5 volts, and it's my GaNs is white or
Right.
light.
It's a higher power. We know that. That's the property of the GaNs.
It's really fast. So if you want the light one, then you can use 1.5 volts and 0.5 amps, for example. That's what I used, and it's producing really fast, and it's light gray.
Okay.
I've heard about the LED drainage. What happens if you use a LED in the MAGRAPH power unit as part of the mixed GaNs? Is it also draining?
Yes.
So it shouldn't be used in the MAGRAPH?
No.
Okay.
This is only a unit for draining for what do you call it? For a specific job. This has a here both units which we discussed by this morning, both the diode and sinc changes hugely the electronic world if they understand how to use it. It changes a lot of things. But we go through it and then I'll speak about it. What do you call it?
Hello, this is Mosfet Rashid. I had some.
Can you speak louder, please?
This is Mosfet Rashid. I'm in LA, Los Angeles, and I had some experience with LED GaNs 2 months back, and I used 1.5 volts, and where I connected my LED to my negative to the nano-coated copper, it created circular motion of GaNs on top of the salt water, one going in the clockwise direction, the other going in the counterclockwise direction. I don't know what that is. I posted this on some forums, but I didn't get any response. So this
if you post it on the Keshe Foundation forum, you get some response. Where do we know where you are?
I put it in the Keshe Foundation forum, but nobody responded. But anyway, it's my experience, so I'm just sharing it. I used 1.5 volts, and the current was about 2.8 milliamps.
But you don't need to use the power. You know.
Did you use seawater?
No, I used just regular water.
Salt water.
Yeah, salt water.
You see, this is something I see a lot of comments everywhere about different behavior when you use seawater. And does it mean the water you collect has all the minerals and the other one doesn't have? That's why you see it's a different behavior. Does it have to do anything with the content of the metals in the water which you get this? We've seen this circulation in other places and other tests.
But there were two separate ones, and
yeah, counterclockwise.
But seawater is a salt, Mr. Keshe, from the sea. It's dried.
No, Mr. Armagolan, there is gold in it, copper in it, zinc in it, everything. And if you pick it up from Los Angeles, a huge amount of radiation from Fukushima. So your test is not like what he does or like what is done with the pure water. This is what a lot of us ignore. We cannot ignore. The seawater from even we collected from the seawater gets mixed up, but still each seawater is different. That's why we have different animals in different part of the oceans, because of this content of the things in the sea. The sea is exactly like Earth, the solid part. You can't grow grass in some places because of the condition, and you cannot grow palm tree in some other places because of the coolness. Sea is the same, there's no difference. That's
What
why
about
of the condition you can have animals. Pardon?
What about sea salt? It's not the same?
Sea salt, where did the salt come from? From a sea, from somewhere.
Yes.
It's the same property, with liquid or without.
That's what I'm saying. It's a sea salt is the same property as a seawater.
Yep.
Because the salt came from the sea.
Yeah, but the present sea salts are mainly drained of all the materials.
Yeah, it has to be unrefined.
Unrefined. It's the best thing is just go and dig a ditch and put something in it and let it dry, bring the water and see what you collect. Okay, carry on, Brennan, we're learning. Thank you very much.
Okay, by the way, on our bead circuit, please never connect the beads in series when you connect the whole system on the grid. Never do that in series.
Can you explain.
For example, we have, I'll just draw on the other page or the previous. We still have the previous page. Okay. When you do this connection, never connect this part here to the grid. So never, when you do this. This configuration is for off-grid testing. Because this you have a high, let's say 110 volts up to 20 volts passing through here. It will light up your house. You will see flashes of, if this cannot survive with a surge of, because it is in series.
This diode connection is for only when you use a plasma batteries.
Yes, correct. It should be
very clear. Yeah.
This is for safety. People might forget, they connect like this, then they connect the grid. So I experienced this will one bead blow out, though it will work still the same, but yeah, it blows out. Just because you have a different signal that is in the moment you switch it on, it will blow out all the beads or the first bead. So this is only for when you connect here the plasma batteries here, not for the grid. Okay. Okay. Let's go back to the GANs production. Okay. We will use this GAN. We have to rinse these GANs, and what we observe while rinsing, it's not the same as my previous GANs like CO2, CH3, and copper oxide. A lot of suspension stays for several hours. In fact, I have to wait overnight for the first for after production. It's slow, very slow. This suspension of white substance, the GANs, it doesn't settle easily, unlike the CO2, the CH3, and other gases. So it's time consuming. But anyway, we waited for it and it did settle, so we're able to do at the second rinsing, and now I'm on the fourth rinsing phase. Okay, we'll use this when you drain the water here from when you're done rinsing the GANs. We'll use this on our capacitor-like setup instead of the usual CO2 GANs, copper oxide GANs. For the paper, that is, we will use this one and we'll use that as our sinc. And I'm thinking of using a different winding. If you have, if this is your paper and this is your inner nano-coated copper, and you'll have to wrap a copper coil here. Instead of the usual counterclockwise, I'll suggest we'll use the clockwise for our sinc. Anyway, everything is nano-coated, so there's still field interaction there, but other than we're conveying the negative winding, it's easy for us also to identify which one is our sinc device because it looks like the same as your the usual capacitor. So still we'll use paper inside. Here, paper. We'll use another color for the paper. It's inside. Wrapping tightly around our nano-coated copper. Then use a winding for your capacitor that is opposite of the usual, say, like this, and like that. Okay? So this will be our new device that pulls the plasma. This will be connected on one end of the circuit and this one on the other end of the circuit. So we have now a new device that encourages flow. We've seen it that we're correct for we're able to replicate what is being observed in the United States when we do these lead guns, when we also implemented it here. Though we have different source of materials, I have a different source of lead, a different source of copper, we were able to replicate, and this indication on the current meter shows we are correct that it really pulls the plasma because it doesn't read anything at all on the usual 800, 500 milliampere. At this time, the production goes very fast that it should have read this reading, it should have this reading, but instead it has this zero reading. For that, we understand it is the plasma that is aiding the reaction. Without the nanomaterials here, you won't get any reaction that produce GANs. Even without this, especially without this power supply, then you connect this with, for example, you connect this with a copper wire or you put an LED on top. Without the nano coating, meaning without the plasma, you won't get any reaction right away.
Can you just go on the last part of the connection as a sinc again, please?
Okay.
Two so different here, colors.
Yes,
use different colors for every part, please.
Okay. So we will draw again the whole circuit.
No, just this part, just the last part.
That's the last part, making the, okay.
The sinc, yeah, please.
So, assuming this is your nano-coated copper in the inside, you wrap it with paper.
The paper is nano-coated with the gas of...
It's your paper, you spread this thin layer of your GANs. I suggest you never touch this GANs. It's not the CO2 gas, it's a different kind of gas that it does not provide you energy, but it pulls energy from you. So it should be rolled on this copper very tight. It should be no air inside, should be very tight. Then you have a coil on top of it. Okay. Okay. Right. It should. Okay. So you have your coil, just like your capacitor, wrapping around where the paper is.
So okay. You put this across the line.
Yes.
One end coming from the grid.
No, coming from your batteries.
From the load, from the
Yeah,
appliances.
from the load, let's say.
Yeah, appliances, and the other side goes to the battery.
Yes. So this is where your load. So you have your connection here. This one goes to your.
Actually, it should go to your diode.
Diode. Diode. This should be your diode. Let's just
Right.
make your symbol for the diode. Okay. This goes to your batteries. The plasma batteries. And this goes to the maggrav unit. So we have a complete circuit. Oh wait, we have a wrong connection here. It should be here. Okay.
And it's all plasmatic.
Yes, all plasma. No external power supply, but it's all plasma. So we have with this.
Now
with this
the question is, we have a problem, and the problem is where we're going to put this battery unit. Do we put it on the neutral side, the sinc and the diode in the container and the battery, and we just put a plug on the other end where you can plug to your load, and that's it?
our battery is here.
No. What I'm saying, you know where you have the load?
Yes.
Where you have the load, if you put a pointer, because you have an option, you block people to be to use the anomaly on your screen. You have to allow the people to write on your screen. You have taken it out in your structure.
It's a different system. It's not the. This is a tablet, not the usual.
Okay. So
maybe it doesn't have the
so
feature.
after the unit, maggrav unit,
Okay.
you make your plug, and you connect your main whatever your supply to this point. So if you cannot share your system, you have to go out, because I use a different system. Then like if you stop sharing them, we make it this way. So what happens is that now we need to build a unit which has a capacitor unit. It has a stacker unit of 3 with 1 bead and a plug point. This side you have a diode, a sinc, and a plug. So you connect this and this into your electricity supply, or your your house after your meter, where here you don't need to connect anymore to the grid. So this is the new generator unit. Please try it and let us know. We are working on it. We've been working on this for a long time, and now with this sync coming in, it brings a lot of things in order. But you need to create, this is mainly on a DC plasma. Your system should be able to drain what it needs from it for electrical system. But if you don't, we have developed a system which sits in the background, which is what we call a delta Y connection. I should say call it like this. And this system gives us the alternative supply. Would you like to explain to us that one, Bernie? So if you look, this is the new power supply. Hopefully, if we can prove it with you lot, because we are doing our part. We work as one nation, one race, one planet. So we all contribute as best as we can. So this is the new power supply without the need for the grid.
Is the LED GANs also used for the beads or only for the sync?
Just for the sync.
Okay.
Just for the sync. So please make this as fast as possible and go with it on the internet. If you see any problem, if anything else, we add the knowledge together. And so we think, if you are correct, we have managed to achieve the generating power without the need for the grid. If you need oscillation, we got Werner can explain to us on the oscillation side, please. Can you carry on? I'm going to share off and stop sharing, and you start teaching us about the system we made a few months ago, where you achieve sinusoidal movement.
Okay.
Thank you very much.
We have for a delta, we have this delta configuration. Let's say you have your coil here. And we combine it with a Y. So these are coils. Each coil is a 3-stacker. We have 3 for each coil, even in the middle. And we connected it. We have here our going out. This one goes here, goes there, and we have here an entry. So this terminal is similar to this terminal. Okay, so we have this configuration. Same also with this one, and we're able to read. And
we put capacitors on the line, on the links.
Yes, yes. I believe the capacitors here are here.
Just put it on different color, please.
Okay. Capacitors are interfacing here. So we take this line and one line.
Different colors, please. Different colors.
We're able to read fluctuating a plus and a minus reading, let's say in millivolts. It's rising and falling consistently, rising and falling, rising and falling. So we have an AC signal from the setup. Remember, each symbol of a coil is like this one. It's the usual mag we have. So 1, 2, 3, and 1, 2, 3 inside. The capacitors here, I believe we have, let me check. We have one capacitor each, yes, on the interface. So with this setup, we've been working this a long time. We're able to read AC from the setup. Yes, we're able to read AC reading, positive and negative. Consistently, it's rising and falling. So if we need a pulse signal like this one, we can use this. We can use this configuration.
Can I go on? Can we change switch?
Yes.
Okay. So we add to the other part. Now what happens here is what we tried was, let's just save. I'll call it generate. What we tried is, what you can try is that we added a power supply, a plasmatic power supply, and connected it to the delta Y stacker. What it does, now that we have added the diode and we add the sinc, and we add, if we add a delta Y formation as we saw here in the system. If I go backwards, I think it'll be better. We add this power delta situation out to go into a stacker and feed out. Now you have both AC and DC at any amount you need. This is your power supply. This is your delta formation, which creates oscillation in what comes through. This is the one which creates you the power. And then this, by you connecting to a load, demands the suction or reverse. And then you should have a full circle. There is a possibility you can put your delta here. So now we see an AC, DC. You can even use a system to amplify this to 220 volt, 4 or 5 amps. Then you need to add the amplifier if you want to work on the current base in the house. So this is the new power generation DC and AC. So today is the 100th time we taught. Now we achieved what we were looking for. Power supply independent of the grid. You can produce every part of it yourself. You don't need to go anywhere. Maybe the total cost will be about, I don't know, $20, $50. Once we produce it, you're looking in the factory cost of about $500 at least for the foundation. Because every piece has to be assembled, built, and this you can use anywhere independent of the grid. So what we said, we might have a surprise for you today. I think it'll be a surprise even to the people who start teaching it, what I was planning to show you. Every piece has been made by Wernicke over past 5 or 6 months, step by step. We have other systems which are made for testing for flight. In time we built it, we can use it. But more or less, now we should have a full power generation unit independent of any grid system. This is what you need. Please make this as, I know a lot of you have a lot of materials. This power unit is your plasma battery set. We reckon 4 parallel, 4 series will give you enough sufficient current and voltage. A delta formation, a stacker with a bead on it. You can have an amplifier, plasmatic amplifier, you know how to make it, I presume. A sinc and a diode, all made of plasma. And at the point, you literally plug all your electricity at the point of the meter into this. You have to create a circulation. What this will do, will give you a physical matter. In time, this will create a plasmatic application in the whole of your house. Very soon, you do not even need this because you can disconnect the physical connections from here the system will feed the house without it. Because the plasma has already interacted with all parts of your circuit, they will take energy as they need from the circuit. So you can put this unit anywhere in the house, you don't even need to connect it. So please try it and come back and share with us. We have noticed a lot of people who take technology this way from us, and they are happy to take the technology, but they are very, 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 very shy to share it, because they think, oh, the electricity board might know, and then they come after me. Now, electricity board is not there to come after you. It's you who have to be correct to come back and teach us. Hello? Somebody's bashing something. So, can you switch your microphone, please? So this is what we call the power generator AC/DC, and you have to allow it to build up. It won't give you what you need in one go. You have to increase it. We go back to another point which is important in this power production. Let me save this one that you have it. Save. We call it generator AC, DC generator. Okay, we save it. There is another part to this too. So what you have made as the plasma unit, which was your batteries, the plasma system, and you added your delta Y configuration, and you went in your system, the stacker unit, you'll find out you need the stacker unit Y in the future, much easier. And then if you wanted, you put a AC, DC alternator on it, you put your sinc unit on it, and you put a diode on it. You see the difference? Now here, instead of using the plasma capacitor, use your GaNs ball. Now, instead of using 80% GaNs of CO2 here and a hydrogen, try to create a vacuum condition with the GaNs, or with the GaNs and the hydrogen in it. What the vacuum will do is that it creates the GaNs to open up in respect to the fields of itself, and you'll find out you don't need the batteries. This is a universal power supply directly from the GaNs ball. And because it's dynamic, it continuously produces huge amount of energy. You can still use the coil on it to create a rotation, but you connect the top of the coil into your system. And in a way, you connect this to the sinc. So you don't need to make the coils. You can test with the GaNs balls you have, and make sure that you have to create the rotation the way we showed. Then you have a true power generation as is in the universe. The sinc here is what I taught you just before when it starts. Is to start putting a LED GaNs at the bottom. But this is a very practical way, because the flow will not be reversed. There is no change of polarity. The system stays stable. Because if you don't put this here, the polarity can change, and it flips over, your system starts feeding in reverse, and you don't get the property of it. So this is what we call the universal plasmatic generator, AC/DC. You don't need to make the batteries. You use your coils and your sphere, and with the GaNs, make sure you get a vacuum that allows the full energy separation. The GaNs doesn't sit on top of each other, and the rotation of it. So you have achieved what we called an independent power supply as a generator. So you can see in time everything you need can be done. But go a step further, and that is now if you look at it, we have start creating plasma components. Now you can start building circuits with the plasma materials. More power, more rapid, less demands, and as much as you need. Behaving like a diode, the sinc, the delta converter, a power supply, conversion, and a pool. There is a question, is there a need for this? In so many ways, yes. Because this becomes the transmitter of the fields in when you become power, what do you call it, wireless power supply. This will become the source of your structure for your, what I call, reversal. It's like antenna, but then you can dictate with what you put here. I'm gonna go home. I don't know why I keep on losing this every time I use it. When it comes to here, by changing the GaNs units here, you can change also feeding, don't feed, whatever you want to do. You want to create a change of a cancer condition, we teach you more and more.
One question, Mr. Kesh, how you can create
yes, Mr. Golan,
in a small ball that we have? Let's
very
say
easy. In a ping pong ball, you can always create. Come on, Arman, you know how to create vacuum.
I'm not talking about ping pong ball, I have a couple balls.
The same. You have to nano coat both sides of it, don't forget. Both sides of this tube has to be nano coated, this ball. Understand why you nano coat these things. Yeah? The reason you nano coat is because you nano coat, the matter state becomes irrelevant. When you nano coat something and you use it in the structures like this, then the nanomaterial inside, the matter state, which is the copper itself, it becomes irrelevant because the fields connects.
Okay.
That's